Hello, today I will be discussing about the eigenvectors and eigenvalue of matrix and what is the eigenvectors and what is the eigenvalue. Okay, and where does it exist? Where does it exist? And what its implication? Okay, so look, what is the eigenvectors and eigenvectors and eigenvalue. And in research work, actually, you should have a clear concept over the eigenvectors and eigenvalue. It has some practical implications. So, without clear idea of this eigenvectors and eigenvalue, you do not have a proper understanding. Okay, so so look, in linear algebra, an eigenvector, it is also called the characteristic vector of a linear transformation, is non-zero vector. An eigenvector is non-zero vector. You must remember that. An eigenvector is non-zero vector that changes at most by the scalar factor. An eigenvector changes at most by a scalar factor when that linear transformation is applied to it. So, an eigenvector of a linear transformation is non-zero vector that changes at most by a scalar factor when that linear transformation is applied to it. The corresponding eigenvalue is the factor by which the eigenvector is scaled. So eigenvalue is the factor by which the eigenvector is scaled. It can stressed by the factor that is called the eigenvalue. An eigenvector corresponding to a real non-zero eigenvalue points in directions in which it is stressed by the transformation. An eigenvalue is the factor by which it is stressed. If eigenvalue is negative, what does it mean? The direction is reversed. If the eigenvalue is negative, the direction is reversed. And we can say in a multidimensional vector space, the eigenvector is not rotated. You must remember. In a multidimensional vector space, the eigenvector is not rotated. However, in one-dimensional vector space, the concept of rotation is meaningless. Matrix actually acts on vectors. You must remember what is matrix. In my previous lecture, you can find some words, some points. But when we discuss about a vector, so the role of matrix is as a weight. It acts as a weight. Matrix acts as a weight of on vectors. If A is a non-singular matrix, in my earlier lectures, I have mentioned what is non-singular matrix. If A is a non-singular matrix, then eigenvalue is 0. Eigenvalue is 0. So, hope you have clear idea that what is the eigenvector and what is the eigenvalue. Now, with an example, I can clarify it very well. Look, here is the equation Ax equal to lambda x. So A is any square matrix and x is the eigenvector. Then it should be equal with lambda multiplied with the eigenvector. Here lambda is the lambda is the eigenvalue. Through this eigenvalue, the eigenvector can be stressed if it is negative If the value of lambda is negative, it is reversed. It's test reverse. And if so, any square matrix is a weight. Any square matrix is a weight that is attached with the with the with the vector x. With the vector x, this vector is called the eigenvector. A is attached to the A is attached to the is any square matrix which acts as a weight of the eigenvector, and it is attached to the eigenvector. And lambda is the eigenvalue by which this eigenvector can be stressed. Clear? So this is the equation on the basis of the definition. Hope you have clear idea. Now, this is an example 1. This is the first example. Let A is a square matrix. Okay. You can find here the A is a square matrix, and the value of this matrix is along the column. We measure along the column there is 0, minus 5, and in the second column there is 1, minus 6. Okay, this is the square matrix. Now, by definition, as I have mentioned, is that Ax equal to lambda Ix. I is the identity matrix, as you know. Okay. Now, after a simple step, we get this A minus lambda I. X is taken as common factor and equal to 0. So, determinant of this part. So, determinant of this part, A minus lambda I is 0. Determinant of this part is 0. So, if A is the matrix 0, minus 5, 1, minus 6, it is put here. So, 0, minus 1, 1, minus 6, minus lambda multiplied with the identity matrix equal to 0. So, this 0, minus 6, 1, minus 6, minus lambda 0, 0, lambda equal to 0. Now, there is minus. So, we subtract this matrix from this matrix. So, minus lambda 0, minus lambda 1, minus 0, 1, minus 5, minus 0, minus 5, minus 6, minus lambda. Okay, equal to 0. So, now lambda multiplied minus lambda with minus 6 minus lambda. So, we get and minus 5 minus with minus 5 multiplied with 1. So, ultimately we get 6 lambda plus lambda square plus 4 equal to 0. After rearranging, we get lambda square plus 6x, 6 lambda plus 5 equal to 0. So, this is a middle term solution. So, lambda square 5 lambda plus 5 equal to 0. So, ultimately we get lambda is equal to minus 5, minus 1 and minus 5. Okay, minus 1 and minus 5. So direction is reversed here. Direction is reversed here. The A is the weight, and it is attached to the vector x, that is the eigenvector vector x, and by using the value of the lambda, this vector eigenvector is stressed reversed. Okay, so this is the use of lambda, and here is the role of eigenvalue and eigenvector. It has enormous use in research work, and without the eigenvalue and eigenvector, you cannot have proper understanding. Okay, so now second example. Look here, A is a matrix 4, 0, 0, 1, and V is another vector. It is vector 4, 4. So now if we multiply matrix A with the vector V, so we get this 4, 0, 0, 1, 4, 4 multiplied this first row, first column 4, 4, 4 multiplied with 4 plus 0 4 multiplied with 4 equal to 16. Again 0 second row first column, so 0 4 multiplied 0 1 4 4, so 16 4. So this is 16 4. What actually is happened here? What happens here? Look, for if I rearrange it in this way, 4 0 0 1, this is the matrix A. 4 4, this is the vector, and 4 1, it is lambda, and 4 4, this is also the vector, So this is the eigenvector. I can read it. I can I It can be written in this way. It can be also written this way. This form can be written also in this way. So here you can find this is a matrix, this is a vector, and this is a lambda, and this is also the vector. So this is the square matrix, this is the eigenvector, this is the eigenvalue, and this is the eigenvector. So matrix is a weight that is attached to the eigenvector 4, 4. Okay, in such a way that it has stressed the eigenvector to 16 4. If we plot this point, what does it look like? Look, look. Now, this is look at this point. This point represents the 4 4 4. This point represents the 4 4. This is the 1 2 3 4. 1 2 3 4. So this was 4 4. This is the vector. This is the vector. And lambda, the eigenvalue for 1, it stressed this vector to 16 4. 16 4. In this way, we count it is the 16 point, and this is the 4. This is 4. So this is the 16 4. This is 16 4. Hope you got the point. How the what is the eigenvector and what is the eigenvalue, and how this can be utilized, and how this can be used in a matrix. Okay, so thank you for enjoying this lecture, and I hope that you got the point, and you have understood the eigenvector and eigenvalue. Thank you very much.